It's my first time at CppCon. I've thought about going for a lot of years and now kind of regretting that I didn't go sooner.
Okay, so good afternoon. Thanks very much everyone for coming. I think this is an important talk for the C++ ecosystem. So thanks very much. So my name is Diego, and I've been working professionally in C++ package management for the last 10 years. So I hope that I can contribute some knowledge here. So let's just start first with a very brief introduction to the CPS, to the Common Package Specification, right? Why I wanted to do this talk. These are the results from the ISO C++ survey from the last year. And they show that basically managing the dependencies, managing CMake projects, CI, all of them very related to package management. They are top pains for the C++ community. I strongly believe that the CPS specification can really help to solve many of these pains. So this is the reason I wanted to do this talk, to push a little bit more about this effort here. So what is the Common Package Specification file? So it's basically when we have a package, a compiled package like Setlib, with some headers, some static library, for example. It's a file that specifies what is in there. So build systems can use that package easily, right? It's not the first attempt done to this problem, right? So we have PC files, package config files, right? We have config CMake files. Both of them very useful, but there's some agreement in this reference there that they have some limitations, right? And the CPS effort is basically targeted to improve and to have something that doesn't have the limitations that are known to these efforts. So the whole idea of the CPS specification is that we can have interoperability. We can have any build system to build something, build a library, build a package, right? And it can create, when it's building the package, it can create a CPS specification of what is inside. And that will make very easily to other build systems or even other tooling to use the CPS files for their build. There has been a lot of previous work on that. So there are previous initiatives like that one of Daniel Rivera and also the other one from Vector of Bull. I'm talking here about the CPS that is in this Git repo. That is the reference, is what we are using now in the C++ ecosystem evolution group that we are meeting monthly now to discuss these things, right? There was also past CppCon, there was a talk by Bill and Brett about this, a plenary, right? And I also did a talk. We were kind of kicking off, putting a bit more push on this initiative. And we have been meeting since then every month to keep talking about these things. So this is basically what a CPS file for the Setlib library looks like, right? It's basically some basic information that, hey, this is an archive, basically a static library, right? These are the headers. This is the artifact that you need to link with. And this is basically what you need to link with it. So the goal of this talk is, hey, I want to push this beyond the specification, beyond the spec that is in the GitHub repo, and provide some further implementation experience, right? Provide tools for the community to be able to test more things, discuss gaps and everything, and lessons learned. Basically push the collaboration that is happening in this group. I wanted to push it a little bit further. I'm not going to talk about the specification itself, right? So it's JSON files, they're there to explain things. I'm going to talk about how can we push this specification further. So I'm going to start first with the creation of CPS files from existing packages. Why? Because we already have in ConanCenter, we have a bunch of packages already. They are there. They can be used today, right? And they also contain useful information, and that will help us to create CPS files. So this is the first part today, is this one, okay? We have packages out there, right? They do not contain yet. It's the goal, but yet, not yet. They do not contain the CPS file for these packages, right? But they contain enough information to generate the CPS files on the fly. And this is the next thing that I'm going to solve. So basically I have this repo here. This repo contains a small C++ application that depends on TensorFlow and OpenCV. Here it will be the CMake list to build this application, pretty standard CMake, right? I also have my Conan file for my dependencies, right? So with these files, I can do something like Conan install dot. This will install my dependencies, right? And I will be able to install and build my application. But I can also use now a new CPS deps generator. So this will install all my dependencies, the transitive dependencies. It will be quick because it's using the precompiled binaries that we downloaded from the server, right? And we can see that beyond the standard CMake file that it generated is the way Conan works nowadays. Preset Conan default to create the project and CMake dash build, preset Conan release. This will manage to create the project and build the application, right? So I could basically run this application. Which is using those libraries and the transitive dependencies. And it's basically this application. But the cool thing is that with the CPS deps generator, if we go to the build folder, and if we check, there is now a CPS folder, and inside the CPS folder, there is a CPS file for each one of the dependencies and transitive dependencies, right? By the way, I'm using here Conan 2.7. I mean, this is already released in Conan. You install Conan today, and you can use the CPS deps generator to try things, right? This also works in Linux. So if I do a Conan install here with the CPS deps generator, then it will install my dependencies, and it will also generate CPS files for me. Here we have the CPS files. They are in a different folder, right? The dependencies are not exactly the same. In Windows and Linux, they have different artifacts, of course, but they're also, the dependency graph is different. So there might be other different dependencies in one case or the other. So I put them, now the CPS deps generator is putting them in two different folders. So you can use both of them at the same time. I can compile in Windows and also in Linux. So this is basically what is done, just adding a new generator, CPS deps. This generator on the inside, what it's doing is something very simple. It's iterating the dependencies, the dependency graph, checking first if there is a CPS file inside the package, then I'm done. This is exactly what I wanted. I wanted CPS in the package. If there is no CPS file yet, then I can generate it on the fly. And then I will be using the CPS from Conan, which is take the information from Conan and create a CPS file from it, right? We have created a small Python package inside Conan. Now at the moment it's Conan.cps file that contains the logic to load, to save, to merge, and to map from Conan and to Conan. Okay, at the moment it's part of the Conan package, but if it keeps growing, we will extract this as a separate Python package, so it can also be used by the community. So where is the CPS package getting the information from? So here we see a little bit simplified a Conan file recipe. This is the recipe that is used to create the packages, right? Those recipes contains the instructions to build and package the binary, right? And it also contains a very important method for Conan recipes, which is the package info method, right? This method contains the information that is needed for the consumers to successfully use this package, right? This is just not real, that was a simplification. This is something more close to the real setlib Conan file recipe, right? It contains the logic because the artifacts will not be called the same. It will not be always set library or whatever. In Windows, the name will be one, depending if it's static or a shared library, right? In Linux, the name will be a different one. All of this is information that the recipes contain, because this makes easy for the consumers. The consumers, they don't need to figure out, hey, what is the name of the dependency? No, it's just here. So then Conan can take this information, read the package info method, see what is there, and generate the CPS files from there. Let's see some simple examples of the files that have been generated with the CPS deps generator. This will be the setlib one, like the most simple one for Windows. One of the things that we see there is that even if the specification you check, and you will often see relative paths with the prefix, right? There are cases like this one, the CPS file is not inside the package. We have to generate it on the fly outside of the package, and then the way that it can specify the header's location or the artifact location will be with an absolute tag. And this is a valid CPS file. The only difference in the CPS file in Windows and Linux will be basically the compile static library artifact name. The rest is, they are in different folders, but otherwise the only change in the specification, in the spec file, is the name of the package. If you recall the package info method, we had to do like a jump there, because the location in the CPS specification, the location field, it should be like a full path, including the artifact name, right? And on the other hand, the Conan file recipes, they contain like the link name. Why? Because we wanted to make it easy for Conan developers to not have to specify, just to make them life easier, right? You specify the link name, which is usually easier, and that's good enough. That means that in the CPS implementation that we did, we have to implement something very similar to CMakefile library. We need to say, hey, we have the name of the library, right? And now we need to search for the actual artifact name and in the possible libdirs location, right? So this is something that at the moment we are kind of duplicating with respect to CMake. But what we have realized, okay, let's move in the direction the CPS is moving. If CPS is explicitly specifying the location and the artifact name, then Conan recipes, let's do the same. We extended the model of the Conan file recipes to be able to you can explicitly put the location field and the type of the artifact right there, and it will be easier to map them to the CPS files. Then we found like a few cases, okay, that something will need to be changed. For example, this is the recipe for the libicon package, and we see that the CPP, the package info method, was super simple. Just basically one line saying there are two libraries, iconf and charset. Right? So there will be an option, hey, we can map this to a CPS file like this one. Actually, what we did, the current implementation is this one. Why? Because we found an example in the CPS spec talking about kind of this, when you have something that is common, right, to a couple of different libraries, in this case, the header's location is the same, you can put it in a different component, right? So the current implementation of the CPS deps, think, okay, there is some information that is common to both charset and icon. Let's put it in a component. Let's make the component private. This is not currently specified in the spec. And I think this is something that we want to discuss, and we want probably to consider, hey, there might be components that they are implementation detail, but users cannot consume them from downstream, right? So there are a mechanism for CPS files to be structured, right? But they shouldn't be used by consumers of the package. There is still one thing incorrect here, which is there is a relationship between charset and iconf. Actually, charset, I think, depends on iconf, or is the other way? No, iconf depends on charset, right? This means that this CPS file, at the moment, it will not work if some of the consumers decides to use one component specifically, because it's not modeling the relationship between both. This is what is missing. But it's not the CPS specification. The default is from the Conan recipe. The Conan recipe was too lazy because, okay, let's make it easy for them. You will always be linking iconf, library, and charset in this order. And then you don't get link errors because you cannot select one component. So this is a lazy implementation in Conan, right? In the Conan recipe. So actually what we will be pushing is, hey, let's do the right thing. Let's do what the CPS specification is advocating for. Let's correctly define the components. And if there is a relationship between these components, in this case, the iconf component depends on the charset library, then it should be explicitly modeled somewhere, right? So this would be the fix that we will do to the Conan recipe of libicon. And finally, a little bit more advanced case, flag. We see that it has two components, and we find a couple of interesting cases here. For example, libflag contains a requirement to an external component, a component that is not in Flag itself. It's in another package called OGG, right? And we will also see some other parts of the specification. There are packages like this one that needs to inject preprocessor definitions into the consumers. If you want to use this package, you actually need this defined. Otherwise, you will not be able to, because the headers depend on this logic. If it is static library, you need to have this preprocessor definition, right? This is something that belongs to the spec. The CPS file should be adding the definitions field, so it's easy for the consumer. They don't need to figure out that they need to add this preprocessor definition, right? So this was in the package info in Conan. It can be mapped to the definitions field in the CPS file. And also, finally, we have the link libraries, which means in Conan it's called system libraries, because these are libraries that are not modeled by a CPS file. They are just in the system. Just do a -lm, and it will work. But it's still part of the model. This lib flag depends on the math library, right? And finally, we see an interesting, the lib flag ++ implementation depends on the C library one, so we can see this detail here. Okay, why this is interesting? Because in ConanCenter at the moment we have like 1,500 recipes with several versions of them, and we have built for different configurations. That means that we have like 500,000 different binaries that you can generate the CPS files today, right? And this can be pretty useful for the community to test things. The thing is that this package info is a bit inconvenient for Conan creators because they have to repeat themselves, right? They have to code this. But thanks, we got like tons of contributions for the community. So the recipes there, we got like last year 6,000 pull requests to ConanCenter, right? That's a lot of knowledge about what are in the libraries. And these packages are being massively used as well. So this means that the package info that is contained in ConanCenter recipes is relatively good. So it's just a matter, there might be bug in our implementations, but let's make sure that we are correctly defining the CPS files as the specification does. And this will be very, very useful for the community. And also finally, this will also work for proprietary packages and any other build system, because at the moment CMake is also leading this effort, right? It can generate CPS files, whatever, but there will be other build systems that they will be slower, right? With this technique, we can create CPS files for Messenger or for AutoTools projects because we have the knowledge already there. Okay, so let's move to another part of this round trip thing, which is there are build systems today, and thanks CMake in this case, that can generate CPS files, right? So I'm talking about this part of the spec. So we have build systems, they can create these files, right? And Conan might be able to load them and to use them, right? In this case, the only build system that is implementing this is CMake. Okay, it was merged like 3 or 4 weeks ago, something like that. So kudos in this case go to Matthew. He's also like pushing a lot in, and I mean he's leading he created the CPS repo, right? And he did like this is still experimental, but I'm going to show it anyway. So here, this is CMake CPS. Okay. Bigger. Okay, so this is of course, this is master branch in the CMake repo, right? I built CMake from source there. You need to define this variable with this very specific UID that it will on purpose change every release. So it will systematically break, and I think it's perfect, right? To make it really experimental, right? And besides this, what you need to add here is a new item you have installed, and there is a package info. As you can see, it's still not recognized by the Visual Studio parser. It's the package info that will be able to generate the CPS files for us, right? So that means that in our Conan file recipe, right, we no longer have to implement the package info method. We can just load the CPS file that was generated by CMake. So that means that basically, I can show you I'm using here the latest, okay? I can do a Conan create. This will be launching the build. The build will probably complain there that this is experimental and you should be careful. what you're doing. And finally, I created a package and I'm using the package from the CPS information. I will elaborate on that later, right? So I wanted to show here that CMake is creating the CPS file, at least generating 2 of them. I will show them in the slides, right? And then that's basically the files that Conan is loading, and then he's using them for the consumers to actually work. Okay, so this was the CMake list that we have seen here. This CMake list generated actually 2 files, right? In the current implementation, and the spec also implements this, right? Is you have like a base CPS file that contains kind of the common configuration. In this case, it's containing the includes headers, right? And the type of the archive. And then for the specific release configuration, it's generating my package add release CPS, right? With the specific information of this release configuration, right? In practice, it means that I only created 1 package, which is the release package. In practice, that means that you want to take both files and merge them together. And if you merge the information from both, you get the full information for the release package that you want to consume. So we implemented this in the Conan library. We have, in the same way that we had from Conan, we have now 2 Conan, which does the opposite, takes a CPS file and map it back to Conan implementation, to the Conan model. And this is one of the things that I wanted to discuss here. And I love that Bill is here, because the file is generated at install time, right? And I have a proposition in here. It will be amazing, it will be fantastic if the CPS files could be generated at configured build time. Why? Because there are tons of cases that you want to depend on the build state, on the build layout of something without having to install that one, right? We call it the Python editable mode or non-install. It can be very useful for debugging, for incremental builds, meta projects with sub-projects, all of that kind of stuff, that if you are forced to do an install, then you are like doing a jump there, and it's kind of inconvenient. So it would be great if the CPS files could be generated at build time. Of course, when you install them, some locations will change from the build tree to the install tree. But what we have seen is that most of the information there is the same, like compiler flags, definitions, system libraries, all of that is the same. It's basically changing some path. So it might be possible to generate the files at build time and then just change the path at install time, or generate a new one at install time. But still, I think it's a very interesting use case here that we want to discuss at least. Okay, so let's talk now to another part of the round trip, which is generating build system native files from CPS existing files. So I'm talking about this. Right now we have packages, and those packages can contain a CPS file inside them, right? But we have build systems, and these build systems will have their own build scripts, right? And there are millions of them, right? It will be very, very difficult to move them quickly in a way to adopt the CPS specification, right? So my proposition here is, okay, CPS files information contains a lot of information. We can use them to generate build system native files that can be used by build systems without having to change them. And this is probably the most complex demo that I have ever done in a conference. So let's see how it goes. So basically the problem is this. We have millions of projects that they already contain a fine package and targeting libraries, right? And they are not going to move quickly to the CPS, to a new thing, right? And we have now a package that contains a CPS file, right? So this can be done. A CPS file can be used to generate on the fly with a tool, a setlib config. I'm simplifying here a little bit. In general, you will want to generate a config CMake file, a targets CMake file, and a config version CMake file. You want to generate all of them, but I think you get the idea. All the information, if you have a correct CPS file, all the information is there. So it's relatively straightforward to create CMake files on the fly. And this is what I'm doing in this demo that I'm going to do. Right? There is only one gap here, and I think this is something that I have also tried to push into the CPS meetings conversations. Is how can we improve the adoption of this? The thing is that the find package and the target, they are using like historical names. In this case, setlib in uppercase, right? Which doesn't match the casing that I have in the CPS file that I'm generating, right? It could be, it's not always the upper or lower case. We have seen packages that let's say the package is called one name and the target is a completely different name, right? And it's not easy if we want to use the existing CMake list files, we cannot change them, right? So there is some information there that at the moment, what I'm doing in my proposition is, okay, I have control of this generation of files, but I am using the CPS file from everything that is there, and to map to existing CMake projects, I'm augmenting the information. I said, hey, the file name should be setlib in uppercase, and the target name should be setlib in uppercase as well, right? So this is something that at the moment Conan is adding it. I think that we should be pushing for the specific, there should be something augmented information for build systems that can help us to move this build system faster without changing the user build scripts. Something very similar can be done for a Visual Studio native projects, right? For Visual Studio, you have properties files, which are XML files. And I have to say, I was pleasantly surprised about the power and the structure. It's relatively easy to do great stuff in properties files. They have conditionals that you can condition on the configuration as well. You can basically map the CPS is relatively easy. You have the fields there and it works pretty well. And all you have to do is generate properties files that can be loaded by the editor, and it will find the dependency and will be able to use the dependency. So this is also possible and works very well. We also have a bunch of projects out there using package config PC files, right? This is the same. Mapping from package config files to CPS will be a little bit more challenging, but mapping from CPS files to package config files should be way more easy, right? So this is what we are doing in our package config depth generator. We are generating PC files on the fly also for CPS existing files. And finally, in the AutoTools or Makefiles ecosystem, it depends. AutoTools is more standard on the environment variables that it's using, like CPS flags and all that. Makefiles, not so much. But yeah, many of them can use them. So that means that basically we can map the CPS files. We can map them to environment variables that Makefiles will easily use, right? And this is what the AutoTools depth generator is doing. So this is the demo that I have prepared today, right? Is I'm going to build an application. This application depends on OpenSSL, right? And OpenSSL in turn depends on setlib. Okay, that's a transitive dependency. So I created these two packages, OpenSSL and setlib, that contains the information of the package. It's a CPS file that is inside the packages, right? And I'm going to build this as a CAM application in these 4 build systems with using the packages with CPS files in it, right? This is the CPS file that I'm using for setlib. It's basically the same CPS file as I told you. In this case, I'm putting the CPS file inside the package. I can use relative paths. So here you see here the add prefix thing, because paths now are going to be relative. And the only thing that changes between the Windows and Linux CPS file for setlib is the artifact name, right? For OpenSSL, right, it's a bit more complicated. It contains 2 components, libcrypto and libSSL, right, which depend on each other, right? The artifact name is different in Windows and Linux, and also the link libraries, the system libraries, are different. In Windows, it will be linking with these system libraries, and in Linux, it will be linking with other different libraries. So we can see here how CPS files will diverge more or less in different platforms, depending on the complexity, of course, of the package that is being created. And the only thing that I added beside the CPS information is I added the CMake file names and CMake target names, so I could use the find package with the default and standard configuration. Okay, so let's do it if I'm able to do this. Okay. I'm going to remove the previously existing packages, because in this case, I'm using two different packages, right, from a different repo that contains the CPS files in it at the moment. So this will be in my app, and let's start with CMake. Okay, so now I'm going to install my dependencies with CMake, and I'm going to specify here that I'm going to use the CPS. The CPS remote is a different server, and I'm hosting there the packages with the CPS files inside them, right? So these are specific customized packages, right? So this is the reason I put them in another repo. So, okay, it installed the packages. That means that I should be able to do the CMake preset and CMake build, and hopefully we release my app. Good. So I managed to build and run my application with CMake. I want to clarify here that I'm using, this is just the Conan file, right? This is the CMake, which you can see is totally standard CMake. It doesn't contain anything specific to Conan or anything specific to CPS, right? So I managed to build this application depending on these packages transparently, just by the generation of the CMake files on the fly based on the CPS information. Okay, let's move to the next 1 out of 4. Let's move to Meson, which is going to be a little bit more complicated, which is Conan install dot. In this case, Meson doesn't have the notion of layout, so I'm specifying a build folder here, and I'm making sure that I'm getting the packages from CPS. Good. I want to show you that the Meson project is exactly the same. We have a Meson build file here that is completely agnostic of Conan and CPS. It's using, in this case, it's using package config. So here we see the package config steps that manage to generate the package config files. For us, actually, we can see them here. It's creating these files on the fly based on the CPS information contained in the packages. So that means that, the first step I need to do is I need to activate the environment. This is not really related to dependencies. This is a toolchain thing. Meson, to build with Visual Studio, needs the Visual Studio prompt activated. And Conan can generate like toolchain files and activation files for us. In this case, it's activating the Visual Studio environment that we need for Meson to build correctly. And that means that I can now use Meson native commands, like Meson setup, native file, equal build, Conan, Meson build. This will be creating the Meson project. Right here we can see some cool things. For example, in this case we are using package config. I'm in a Windows machine, doesn't have package config by default. In this case, the project is using package config from a Conan tool required cell. So it's injecting package config directly into the build. And with this, I can do a Meson compile. See, this will be the build folder. Hopefully this build the project, and I can run my application on the person OpenSSL and setlib from CPS packages with Meson as well. That's 2 out of 4, not bad. So let's move now to the next target, Visual. Here we see that we have a pretty standard solution and the VCX project, right? We have a Conan file that is, come on, you can do it. VS Code, you can do it, yeah. We can see that it's generating the files from the CPS. That it basically means that I can do as well a Conan install. It will generate this props file for us that Visual Studio can load, right? And this means that I can go to my solution. I can open the solution with Visual Studio. I can go to the release. And let's build and run our application. And I got, again, the application running in Visual Studio, native Visual Studio solution from packages contain the CPS information. And finally, three out of 4, not bad. So let's move now to Linux. This is Windows subsystem for Linux, but it's Linux, right? Let's move to my app, to the make folder. Let's make sure that we remove the previous packages, that we use them. And let's make sure that we install the dependencies from the packages containing the CPS information there, right? I told you that in this case, make file is using environment variables. So Conan was mapping the CPS files to an environment variable file. That means that we can source that file, and then we could make our application. And if our application built correctly, we can run our application also without it. That's 4 out of 4, and I love that everything was so smooth. Great. So let's do a quick recap. What we have here, we have, I think questions better at the end if you don't mind. We have here 2 packages, right, in 2 different platforms, Windows and Linux in this case, containing CPS files, different for every different platform, of course, right? And then we managed to consume these packages transparently without having to modify the build systems, just by creating the respective files, props files for Visual Studio, CMake files for CMake, environment variable files for AutoTools, and package config PC files for Meson and package config. You might ask, and maybe that was your question, why didn't you use the CMake generated CPS file, and why you put your own CPS files inside the packages? And well, the thing is that I tried, right? I only had like 3 weeks because it was like too short of time, but I tried. So I tried to do a patch for the setlib package that did the same that I did with the previous package that I saw before, right? I was adding the experimental export package info there with the UID, and I was doing the install thing. And this is what I got. Something missing there. What are you missing there? The headers. There is no information whatsoever about the headers location in this package. And what's the reason of this? And the setlib CMake list is relatively simple, right? And this is one of the issues that I'm concerned. The CMake list files, not all of them contain install instructions. Not all of them contain correct install instructions. And it's going to be challenging to move them. Hey, you are doing it wrong. I can tell you, you go to setlib, you say, you are doing it wrong, you need to change your CMake list, and they're probably going to reject your pull request, whatever. Yeah, and I'm talking setlib, but there will be way other more challenging projects out there that will reject any change there. So this was kind of my proposition. Hey, if we do it at build time contains all the information, everything that is needed to create the correct targets. While the install time might be missing. In this case, the missing part is they are copying the headers with a specific copy command, something like that, right? So the install model doesn't have the information that these are the public headers that it is installing, right? Okay, last item in my presentation, I would like to talk a little bit about the location of CPS files. This is one of our current and constant struggles while working with Conan. So packages, they have the config files or the PC files, right? And then there is always a logic to resolve the location of these files, right? In CMake, you can use the root variables, you can use the CMake prefix path, and there are tons of factors there that affect the resolution order. And we have found even some complicated use cases that we haven't found a solution yet to be able to define the correct order to find the correct CMake files in different locations, right? We will elaborate on this a bit later. Something similar happens to PC files, right? We can have a couple of locations, we have an environment variable with the folders, but still it's difficult to do this. And this will only get worse when we have something like CPS that allows to use more packages with more versions and more configurations, right? If it is easy to use packages, we will more easily, hey, I want to do different things with different versions. So we will have this situation, something that we encounter every day within our Conan users, right? I have one application, and I want to build this application for some reasons, business reasons, right? With OpenSSL, this version, setlib, this version, and both are static libraries, release mode, and both of them come from a package manager, right? But at the same time, they want to build this exact same application with the same source code. And for some reason, business reasons as well, they need to link with OpenSSL insert mode that will be kind of embedding the setlib static library will be embedded in the artifact in the cert library of OpenSSL, right? And I need this for deployment purposes to my customers. And for other reasons, other customers maybe that they will not accept using OpenSSL 1.1, I need to do yet another build of my application that will be using different version of OpenSSL. It will be using a different version on setlib. And again, this can be changing. And finally, I have use cases that some developers or a developer might be using a local build of OpenSSL, which is in a local, they just build locally in one of their folders. And they will also have setlib in a sysroot because they are doing like cross-compilation to a target, whatever. And so we have very different scenarios, right, of different packages, different binaries in different locations for different versions that we want to use, right? And the ideal is that we can use the same CMake list for all of them, because you don't want to start to put in your CMake list, hey, if I'm doing that, I need to use this specific CPS file from this very specific location here, because this basically doesn't scale. It will make your CMake list like unnecessarily complicated. So this is the proposition, right? I think you know that I've been advocating for this for a long time. I think this should be part of the CPS specification, right? If you recall, let me check. No, not this one. If you check the first project in the CPS folder, I was generating 2 folders containing all the CPS files, right? I already also generated the locations file. So for every Conan install of the dependency that you are doing, I will be given a JSON file that contains the location of the CPS files that are being installed by this very specific install. And I'm doing both of them for the different platforms that I'm using. So this can be super useful to make it explicit, all right? And this is already being generated by CPS steps, right? Why? Because if we have this in place and the build systems can use it, for me, it's a user thing. My app in platform 2, I can build it and say, hey, these are the CPS files that I want you to use, right? For the other build, say, no, in this case, I want you to use 3.2 and the shared library, right? And this will always be, and for the last case, you can point to your local build folder, right? And to the sysroot folder, right? And everything can be very nicely explicit. We talk to hundreds of users and companies. And this is not a concern. Actually, this is a feature. Being able to explicitly specify the resolution of the dependencies, the location of the CPS file is perfect, right? Another major advantage that this approach could have is something that will inevitably happen. I know that we want to prevent it. I know that we will probably try to specify in the CPS specification. We will try to put there like common package names or like a central registry that you can put package names. Even if we do that, it will not scale. And we will have situations like this one. We will have OpenSSL that has a requires to setlib. And then we will have another user, but for some reason, they create another package and they depend on setlib. But the setlib, it was their specific build of setlib, right? And they, for some reason, they named it differently. They named it my setlib, right? But this setlib is just a build of setlib, right? Now, if we want to use both packages, we will have a problem because they will try to use two different identifiers. We don't have an easy way to map them. No, both of them are the same thing. And both of them will be located are the same setlib.cps file containing the artifact that we want. That means that we can use this mapping file as a resolution mechanism. Everyone sometimes use setlib, use this thing with its own targets defined in the CPS file. If you're using my setlib, you're requiring my setlib, fine, use the same. And you can map them explicitly to the file that you want to use. And this can help a lot, in my opinion, to solve many problems that will happen. And this is not opposed to search policies. We can still have all the benefits of automatic deduction, automatic finding of CPS files, right? Just is you have yet another input from the user. If you have the location of them, just use them. If you don't have them, apply your search policies and find the CPS file for me. You can have both perfectly. Actually, it should be just an if in the search procedure. Say, if it's already in the JSON file, just I'm done. If not, just go and find it, right? So it should be pretty straightforward for search policies. And the good thing is that if after the search policy or the search procedure has completed the JSON file with all the CPS that are actually being used in the build, for example, if it saves that file to disk, we could have many other tools benefit from that. So software bill of materials, right? It's so popular, security and everything. For software bill of materials, what you need to know exactly the location of the CPS files that have been used in the build. But a tool that is collecting an SBOM, the bill of material, the SBOM, doesn't want to replicate all the fine logic that CMake is implementing inside the build. So how can we make both tools work nicely together? If we have the build system outputting, hey, these are the files that I used, then SBOM can go there, grab the files, get the artifacts, generate the SBOM, and everything will be smooth. So I think this will be a great benefit of having this explicit mapping. Okay, we're good. So lessons learned and conclusions. So first, lesson. Talk is cheap, so many code. I think we need more of this. We have been discussing for the year, and I think nothing compares to having code pushing, having something, even if it's wrong. I'm pretty sure that there are some misinterpretations in my reading of the CPS specification. I want to know them, but if I don't push for them, I don't have what a pressure. I don't do this, then we will not move forward, right? The spec is good. The spec is good. Actually, I found it's a bit is missing. For example, a bit more full examples. We need some example. Hey, this is the setlib library. It was built, these are the artifacts, and this is the CPS, or the CPS files. One file, if it is merged together, or it was a release, it will be these two files, and we will need like this. I think we need a bunch of these examples explicitly there, because they really need to understand what is right and what is wrong. We need best practices. For example, the private implementation is not in the spec. Maybe we don't want to put it in the spec, we want to do like Python. Say, hey, if you put an underscore, it means you shouldn't use it. If someone uses that, it's not blocked. The specification will not block its usage. Yes, it's your own risk. We can do it, but better specify it in the spec. What are the best practices? I had some troubles understanding the merge of this because it's not a JSON merge, right? So having examples about different configurations CPS files are merged into one would be super nice. The other lesson learned, generating CPS files from existing CMake list will be challenging because our experience is that the CMake lists are always not correct, right? There are missing things, so the CPS files will likely be incomplete, right? And from our experience is maintainers of the projects are not always that happy that their CMake lists are being changed, right? So in this case, if we could try to generate CPS files at configured build time, the CPS file qualities will be much, much better. right? And this will lower the barrier of adopting things. And this basically is the usability in existing projects. I think is very important. This is one of the reasons that I wanted to keep pushing on the mapping from CPS to existing build systems, because this will be critical for adoption. So that means that we want to keep defined packages. I know that in last year talk, there was a proof of concept using a explicit load package in the CMake list. But the problem is if we have CPS files that are not fully correct because the CMake install code was not fully correct, and then you have to change your CMake list to put their load package, and it will not always work, developers will be reluctant to go that way, right? So how can we speed up adoption is, I think we need the mapping to build system. I think it will be very important for adoption. And we need to discuss about the extra information that will be needed for this, right? It's mostly a couple is package config. There are also packages there that contains custom names that doesn't fully match the library name. In package config, there is no concept of components. So there are package config files generated for every component, but also the conventions there sometimes the components names is not exactly as you would expect. So we might need to check, hey, if we want a transparent mapping so existing projects can adopt it, we might need to put extra information somewhere else. So my conclusions here. I hope that I've managed to push a little bit more the CPS effort, because I think this is very important for the C++ ecosystem. I think it's one of the things that can really improve the ecosystem. And we will stop hearing, hey, but I want a Cargo-like tool. Yeah, I know. We are trying to improve things. It's not easy. It's not the same ecosystem. And I think the CPS can help in this. We have provided a very large public set of CPS files and packages that you can try today. I think it can be very useful to test implementations, to iterate, and this can also work for private packages. So this we hope that this can be very, very useful to benchmark, to try things, to test other tools together with Conan. We have also done preliminary testing of CPS. I was so happy to see the CPS generated by CMake. Okay, and I hope that this feedback is also useful to keep it moving. We have proved that it's actually possible to map CPS files to build system native files successfully, transparently. I'm not saying it's an easy thing, it's an easy effort, we will need effort, but I think it's doable, it can be done, and it should be done if we want to have like a smooth adoption of CPS. We have also discussed the location of CPS files, the challenges there, and possible gaps. And we have proposed, hey, we should add something to the spec in this case. It shouldn't be something external. It could be part of the spec itself. And as a future work, something that we will hopefully be working together is, okay, let's continue validating with the CPS community. There is also work there with package config things and other tools for CPS. So we can probably start trying things together and trying to collaborate more with this. We have already started to contribute a bit more on the CPS GitHub project, okay, like reporting small things, discussing more things. And with all this, I think we are in a good place to start like pushing this a bit further. So I think this is the next thing that should be done. We should be, in our meetings, monthly meetings, we are talking about it. We should be probably soon be discussing pull requests. There are, hey, this is pull request, what we want to do. Is this correct? No, we want to, and have them discussing about the code, actual the spec, on top of general discussions that we are having. We haven't implemented far in Conan the executables model, because Conan itself doesn't have a explicit executable modeling in packaging, right? This is something that we have started to do. It's not a priority, because the priority is libraries. Of course, solving libraries will already alleviate a lot of pain in the community. And hopefully we'll start iterating and closing the loop with CMake and other tools providers. If the CPS component in our is valuable, we will take it out and we will make it available for the community. It might take a while. So that was my presentation. If you want something else, you can find us in the Conan booth. If you want to discuss something about the Conan implementation of the CPS, go to the first two links there, either our webpage or our GitHub repo. You can report things there in our GitHub repo for anything CPS related. And if you want to discuss something more general to the CPS specification and the effort that is being done in the ecosystem evolution group, I recommend joining the CppLang Slack ecosystem evolution group and also checking on the project there, reading what is happening and so on. And that's all. Thanks very much. We started a little bit late, but there is a couple of minutes for questions yet. If there are any questions in the audience.
Hey there.
Oh, thank you.
Yeah, great talk. Thank you. You mentioned in the example for where you generated for zlib the CPS file from CMake that it was missing the include path.
Yeah.
How would I need to write my CMake lists files so that this doesn't happen and the include path does show up?
Yeah, that's a good question. So typically what you want to do is what I did in the, not this one. This would be CD. See, that was the CME. So if you do this, which is the recommended CMake way of doing things, it will correctly output the include headers. But zlib is not doing this. It's doing an install command, an extra install command here to copy the headers. So then CMake is not aware of the include directories for the basically the install for the install interface. So if it's not aware, then CMake cannot do miracles. It do great stuff, but it needs to be aware. And the problem is zlib CMake this is not doing this. Sorry, what?
If you use the file set headers, it should work too. Right?
Yeah. Probably. I mean, there are people here in the audience that know better than me, but I think so.
Okay, good. Thanks.
Thank you.
So I know your talk was all about like programming language packaging. So my question is, how much is this ecosystem evolution working group working with people like systems packagers and distro packagers, and is there any interest in CPS from people like that, like Debian or those folks?
That's a very good question as well. Of course, because this is not really specific, even to C++. zlib is a C package, right? So there will also be interest. At the moment, I'm not aware, maybe Brett knows better, if there is someone in our meetings that is from a distro or a system package manager. I don't think so. I think most of us are from the C++ community. Probably we want to extend it to a larger audience, like distros and once we have something a bit more mature. We are considering their use cases. We are considering the zlib and C packages, and probably most of what we are doing might be good for Rust packages built outputting like a static library or whatever. It can be, but probably we want to put our things in order first, have something that works for us, CMake, Conan, C package, but all the players in the C++ arena, and then when it's kind of looking good, I think we will chase the other communities when it's a bit more mature. That's my take, but probably we want to align with the other C++ Brett. I don't know if you have something to say.
If people are interested, they should reach out.
Yeah, but something to talk about it. Yeah, at the moment they are not involved. We would love them to be involved, but we are not actively chasing them to be involved that much, and we will probably wait a little bit for that. But
we use system packaging in-house until.
Yeah, good. Thank you. Any other question? No. So thank you very much for coming to my talk. Thank you.